And 1 second.
Yep.
Here we go, Stuart.
Yeah. So I will apologize for having to hurry this somewhat. It just fits in an hour if you want about 5 minutes worth of questions at the end. So please hold your questions to the end, and I'll try and deal with whatever I can. Let me share this. Let's assume that you guys can see that.
Looks good, Stuart.
Okay. So as Mike said, Agile and systems engineering. This came about because several of my customers started either being, what shall I say, enforced by their larger corporate bodies to try Agile in their systems engineering, and variously we're looking around for experts who might be Agile with systems engineering. And it got to a point where I was being asked so many times, I thought, I'll write a paper. So I did. And I was lucky enough to win the best paper prize at INCOSE ASEC 22 this year. So, so you're going to get the benefit of that. So what are you going to see? Well, what I want you to take away is what Agile really means in the context of systems engineering, and recognize why that's different to the software documented texts. It's about context, I suppose, ultimately. So we'll explore that. What elements of an Agile approach can be used in the process of engineering systems, and what quantitatively you should avoid. The limitations of Agile for systems engineering development, especially around complex physical systems. Most of the system engineering I do with my customers tends not to be IT systems, virtual systems. It tends to be things that move the real world. So my bias here is very clear and my context is very clear. It's about complex physical systems. So the content, I'm going to go through some definitions and scope, as you'd expect from a systems engineer. I want to make sure we're all talking about the same things with the same terminology. I'll look at the original roots with the Agile Manifesto, and then I'll go through some of the typical SE references that you may well know about, including Mr. Powell Douglas's books, which I know he did a series of webinars, must have been about a year ago now. So we'll cover some of that. He's a good source of material, even though I draw different conclusions. And I'll look at the SE handbook and Scaled Agile framework just for sort of reference. And then we'll dive into that contextual difference between software and system engineering. And then I'll try and rewrite the software Agile Manifesto from a system engineering perspective, which hopefully will try and secure the ideas in your mind. And after that, if anybody's read Bertrand Meyer's book on Agile, which was very much software, but a really good comparison of lots of different Agile practices, I'm going to use his pattern for the brilliant, the good, the hyped, the bad, and the ugly. And then we'll just wrap up with some conclusions. So definitions, agility. So in my view, agility is the ability to respond effectively to change. And generally, that's considered to be unpredictable change. That's important because it'll crop up again later on. System engineering, I'm not going to bother with. You're all system engineers, so I'd expect you to have met one of at least a dozen or maybe 100 different definitions of system engineering. But the big reminder for me is that system engineering was born out of a need to solve problems, not addressable by incremental changes. And it's really worthwhile reminding you of that wording, that explicit wording from Bell Labs, and we'll come back to that. What I'm going to address is Agile systems engineering, i.e. approaches of using Agile processes for engineering systems, and which is sometimes abbreviated as Agile SE. To be clear, what's going to be out of scope, therefore, is Agile systems engineering, i.e. the generation of reconfigurable modular systems, etc., that allow you to compose different solutions on the fly from the components. I've spent a lot of my life in product line engineering, and believe you me that Agile systems run counter to a lot of our traditional system engineering, because you don't concentrate on the optimization, you concentrate on flexibility, and you do that for a known set of variations or configurations or permutations. And commercially, they're quite problematic, shall I say, because what do I validate? Do I validate one particular instance that I'm configuring, or do I validate all possible instances? Who's in charge of the reconfiguration, and how do I validate it? How do I validate performance across all those things? There's lots and lots of stuff in there which makes them awkward, shall I say, from a commercial perspective. So let's have a quick look at the Agile Manifesto. I'm not going to dive too deep in this because I will rewrite it. But look at some of the things they hold as principles, and I put a question mark after principles because not all of them are principles in my book. They want to satisfy their customers. They do that through continuous delivery of valuable software in their mantra. Not sure I understand some of those words, but we'll come back and sort those. They welcome changing requirements according to their manifesto. Personally, I've never welcomed change in a program that upsets my potential for delivery or product or quality or all sorts of things. But okay, I understand the principle. Deliver working software frequently. So there's always this agile view of the world that you're as good as the product you last delivered, and that was only a few hours old, because you're always renewing a capability for your customer. Business people and developers must work together daily through projects. So I think that's pretty normal. Why wouldn't you talk to the business that's asking you to contract the work? Build projects around motivated individuals. I have some issue with. I have an even more issue with the now somewhat outmoded idea that face-to-face conversation is the only way to communicate. Working software is the primary measure of progress, so they don't care about anything else. It's about what works. And agile processes promote sustainable development. I'm not entirely convinced by that. This appears to be something which is about making sure the project manager doesn't beat you up too much. Continuous attention to technical excellence and good design enhances agility. I reword that and I have a slightly different take, but maybe it's the same message. I don't know. Simplicity, I have a very different view on. Simplicity for me is not the art of maximizing the amount of work not done. In the agile world, anything that is not product is waste, so you don't do it. The best architectures and requirements and designs emerge from self-organizing teams. I think there's plenty of evidence around the patch to suggest that's not true. And at regular intervals, the team reflects on how to become more effective. So yeah, feedback, I think that's always really useful. So let's really have a go at the first thing that practically all the agile texts make a uniform mistake on. And I've taken this from Mr. Powell Douglas's book, and just as a diagram, just to illustrate the problem. So he suggests that the V model implies lots of bureaucracy, rigid definition, design approval, sign off. So you slide all the way down the design side, you get to this handoff, you give it to the implementers, and then they implement it, and gradually it gets validated after it's implemented. The bit that's sort of assumed in here is a linear single pass description of the system. For me, that's not really where my life has been for the last 40 years. So I'm surprised to see people still interpreting our life cycle like that. So the incremental life cycle attempts to close the top of that loop and allow you to iterate around it, which I don't have a problem with, I suppose, per se. But Mr. Powell Douglas makes two really good observations, and they're very useful. And I've picked them out in red and green here very deliberately. And we're going to refer to these all the way through. So the first one is the user story, i.e. the element that you address in an increment in one of your cycles, it can be implemented in one iteration and is independent from those in other unrealized user stories. So for me, as a system engineer, one of the most powerful tools I use is the use case addressing the need of one of my stakeholders. And it's rare, I would say, that I come across a system where the use cases are all independent of one another. Part of the nature of complexity is that there are lots of connections. And his second observation is the amount of work necessary to refactor existing designs and implementation to accommodate new functionality is much less, i.e. much less costly, than to implement the new functionality. Now, for business process systems, virtual systems, software-only systems, that sort of makes sense. I can believe that rearranging the software doesn't cost that much. But for those of us who have to commit physical hardware, electronics, etc., and potentially manufacturing tooling, etc., that one's a hard pill to swallow. So let's start with the first assumption anyway. So it means to create user stories that represent coherent system functionality, we should expect to find use cases that map onto a single requirement and vice versa. So as I say, I rarely come across systems where I have a nice singular independent use case. So let's just look at iteration for a moment and look at the V model in iteration, because part of my life, certainly best part of 40 years ago, I was doing something which looked somewhat like this, i.e. phased V life cycles, where an element of the system, a feature of the system in general, would be started down the design stage. And at the point you hand it off to the implementers, you'd start the next design stage, so that you were always at a phase, which gave you a sort of optimization of resource usage by skill type. So your system engineers plowed in first, got the feature defined enough to get going, got the implementer started, and then they carried on looking at the next feature. And this really was recognized by Parnas and Clements back in the 1980s, where they said, well, okay, the ideological linear process flow is not really practiced. Really what happens is this sort of staged iteration. And they actually documented that in this paper, A Rational Design Process, How and Why to Fake It, back in '86. So for me, this was a very real issue. This is how I came up. This is how I did things. So phase development required some upfront analysis, obviously, to be able to break it into the features, but was used long before Agile appeared. And as I say, optimized skill usage. But these diagrams, as they're written, they suggest that SE of the next feature can start before the implementation is complete. So if I talk about Agile, is that acceptable in strict Agile? Well, of course, the answer is no. In strict Agile, you have to complete your iteration before you can start a new iteration. So you have to do the entire life cycle before you can start the next stage. And there's sort of good reasons for doing that in the Agile world, but I'm not entirely convinced they read across to SE. So it's nice to see Dilbert cartoons in our own SE handbook. And this one really goes well with the conception of Agile. So, why don't we just get all the requirements ahead of time? Don't matter about that. Let's just start designing it. And if you read between the lines of Agile, there's an element of, yeah, don't bother with documenting things. Get on and make the product. Okay, so this was reinforcing the need for a system engineering process. As I say, it's in our engineering handbook. So back to Mr. Bell-Douglas. He very nicely says, when I talk about Agile system engineering, I mean developing systems incrementally. Okay, that seems reasonable to me, but just remind ourselves of those Bell Labs words. So one of the key concepts in Agile software development is that developers are never more than minutes away from demonstrating that something's correct. So this idea of having a trail behind you that is successively increasing in capability, increasing in content. You never go back, you're always adding capability to what you've done so far. So to implement that sort of idea in systems engineering, I think there is some reality to the statements he makes where models are absolutely critical. In my world, I'd much rather validate at a model level that my concepts have legs, that they can work without starting to commit possibly very expensive implementation or invest in tooling or whatever. So I'm wholeheartedly in agreement with, let's prove that what I'm trying to engineer can be devised, can go together, looks like it'll do what the customer wants. And that seems to be a reasonable thing. But of course, in the Agile world, there's an element of saying you're not allowed to invest in that because that's waste. It's not part of the product. So the success of incremental and Agile methods in software development, again, Mr. Powell-Douglas's word, is due largely to the ease with which software can be refactored. I agree wholeheartedly with that. So Agile works, incremental works, if you can refactor it cheaply. So with software, that second assumption is met. But if I start to take apart then the difference between system engineering and software development, again, I'm going to use Mr. Powell Douglas's words because they're really quite useful. The outcome of software development is implementation, and the outcome of system engineering is specification. Most of the job we do is about deconstructing a system enough to be a handoff specifications to individual domain disciplines in a coherent manner, such that once they've implemented all their pieces, we can be pretty confident that the pieces, when brought together, or all the technologies when brought together, will do the job that we expect them to do. So specs are really what we're about. Software is easily refactored. Systems in general are not. And I think what he's got down here is really important. You know, refactoring electronics means a recall. Refactoring the mechanics is retooling manufacturing plant. These are significant investments. These are not things you want to change just because you forgot to consider something, because you didn't take the time up front to consider what the product might need at maturity. If I was to talk to my electronics guys every 5 minutes to say, you know, I said I only wanted 3 of those. Well, I want 4 of those. Oh, and can you put another hole in the case, please, to do that? They would not be very happy with me. Yeah. So that means we can invalidate the underlying agile software assumption of easy refactorability for system specs because of those costs. And just to make sure we understand Bruce's sort of background, he says, software development is really invention. Invention's highly predictable. Actually, in the electronics and mechanical stuff, you just join stuff together. You know, that's the easy stuff. It's software that's really difficult world. But I suppose if you are a software engineer most of your life, you might relate to that. So the benefits of Agile SE. Primary benefit is claimed to be quality improvement. So I suppose if you're feeding back to your customer on a regular basis, you might expect that you are going to define something which is more aligned with what the customer wants than maybe your reference point being you talk to him once, he passes you a spec of requirements, and then you deliver a product some eons later. Again, not my world. In fact, my world of even 35 years ago was spending lots of time building test equipment to make sure that the bit of the feature that we did develop actually worked and we could validate it with the customer. He also goes on to say that big design up front and big bang integration, both products of this linear view, single pass V model, cause all kinds of problems. And I'd agree entirely with that if that's the way that we did things. So ensuring your system engineering specifications are correct right now, even though if they're incomplete, sounds useful, but it actually has a bit of a problem in making sure that you only have these independent cases. Otherwise, you have a potential for invalidating what you've done previously. So I'd précis that as say, models allow us to validate and demonstrate a correct but incomplete system to the customer. But I would go on to say that Mr. Powell Douglas has missed or doesn't admit that further change may invalidate that evidence because of the dependencies, basically. I'd also contest his claim that big design up front causes inappropriate architectures any more than incremental approach does. I think it really depends on the level of design investment. To me, getting the concept right, getting the partitioning right, looking for the coherence, cohesion type arguments is really, really important in making sure that I'm getting an optimal solution. And here I'm using the usual triumvirate's view of architecture, i.e. the set of significant decisions about the organization system. So for me, architecture is about those significant decisions. I don't see that introducing something I hadn't thought of later is going to give me a better idea than maybe understanding conceptually all of what I need to do, but at a high level, not at every concept and detail. So Agile requires incremental approaches, and incremental relies on 2 assumptions. The use cases implemented in one iteration are independent of those in the other, and the amount of work necessary to refactor existing designs is cheap, basically, and much less than to implement new functionality. So the evidence against assumption 1, independent cases may cause low integration for physical system optimization. That's even documented in our own SE handbook, the expense of infrastructure modularity. We can attempt to make things more independent, but there's a compromise to be had in what we achieve in terms of product. And that's usually penalties in volume, mass, power, thermal. These are the things that you see in the Agile systems engineering type view of life. Apologies. So that means that largely the underlying assumption of independence is invalid for my context of complex physical or cyber physical systems. The evidence against assumption 2 is that software is not physical and can be refactored easily. Systems, when constrained by physics, aren't. As we said before, refactoring electronics means a recall, refactoring mechanics is like required tooling. These are big investments. So that means the underlying assumption of easy refactorability is largely invalid for the systems that I certainly deal with in terms of complex physical real-world products. So I'll just go back to the Bell Lab statement. So SE was born out of a need to solve problems not addressable by incremental changes. So I'll just go back to the beginning. Agile requires incremental approaches. Yet SE was born out of a need to solve problems that are not addressable by incremental changes. Bit of a clue, I suppose. So let's just look at the Scaled Agile framework as another frame of reference rather than just Mr. Baldogl's book. You will notice in the Scaled Agile framework, there's some implications for system engineering. I know it's in tiny script, but that's also about the scale. You'll see it in the Scaled Agile framework. And it appears again, if you look very closely down at the left-hand side, the system architecture and engineer appears in here. So that seems to suggest that there is system engineering ideas running through Scaled Agile framework. But unfortunately, when you dig in a little bit, you find the system team is a specialized Agile team that's system building and supporting the Agile development environment. In fact, they're largely the build and deliver type team. So they construct, test, and deliver the product. Not really the normal system engineering use I would give. So in the Scaled Agile framework, system engineering has a non-traditional scope, shall I say. So it's designed to support tools and methods of large-scale IT-type software developments, generally software developments. It addresses scale, but not really addressing complexity because it still has this view of independence or largely independence. And it has an IT solution style view of life, which is maybe commercial off-the-shelf hardware that can be swapped out. It mentions the attributes of cyber physical systems, but really doesn't have any solutions to them. Again, it has the flawed comparison of the single pass to the V model, but counter to strict Agile, at least it does preserve some options. It does think about what you might need to deliver for future. So it does invest in non-product. One of the bits that sometimes is a bit difficult for some customers, certainly in the high integrity world, in the Scaled Agile framework, evolutionary delivery is a bit like a Tesla car. It uses programmable technologies for iteration. It allows you to do over-the-air updates. For those of us who worked a lot in high integrity world, the idea of having programmable technology that can be changed under your feet, potentially invalidating any testing you've done or having to start again with all your tests, because unless it's the real code running on the real target, you don't really trust it. That can cause a concern. Certainly if I was in nuclear or was in space, they would have a concern with that. I would imagine in most rail outfits, you'd have a bit of concern with that. And architecting the system assumes independent features of the system, or at least sufficiently independent to allow you to develop those features in independent scrums. Yeah, so let's just look at the SE handbook, because that has, in the new version 4, has a section on Agile SE, which to my mind can be a little confused. There are some things I accept. So it says agility is a capability exhibited by systems and processes to sustain effective operation under conditions of unpredictability, uncertainty, and change. I have no sort of problem with that. I think that's a good definition of agility. The value proposition is risk management. Appropriate when development speed and customer satisfaction are likely to be affected by requirements understanding that evolve during system development. Bits of that I quite like, bits of that I don't like. If I was evolving a requirement with a customer, an agile process of iterating fast with him what he really means by his requirement seems actually very effective. Doing that iteration through the long duration of a system development, a little more difficult. The bit that I have more problem with is the bit that says Agile systems engineering and Agile systems engineering are two different things. Tick, agree with that, with a shared common architecture. I'm not sure where that propped up from, because I don't see anything that suggests there's a shared common architecture between Agile processes for system engineering and Agile systems engineering, which is about providing a modular architecture. And an Agile system architecture incurs expense in infrastructure modularity. Yes, I agree entirely. That is the problem I've always seen with Agile systems, is that you're doing away with this lovely optimization step for the choice of your reconfigurability. But it says here that agility is the ability to respond effectively to surprises, good or bad. And yet goes on to say practice and technique should be chosen for compatibility and synergy with the nature of the project. So there's an element of those references that suggests you will understand the types of surprise that you will get by the nature of the product or the technology that you're deploying. So they're not really surprises in some respects. They're things that you could imagine might happen because of the solution. So the forecast of likely change, not necessarily the unpredictable, I think is how I would state that. So building in modularity doesn't endow the ability to accommodate unpredictable or assure effective operation under arbitrary change. That's the point. So if I go back to what Agile's sort of mantra was, well, let's accept any change and we can deal with it. So it's unclear to me what makes a particular system agile given an unpredictable surprise. So let's just try and put the context again for between the software and my world, the cyber physical system. So entirely realized in software is a virtual product or a virtual business process. Interfaces between components or externals have no physical substance. The refactoring for architecture improvements is basically quite easy. I mean, moving stuff around in software, assuming here that refactoring means not changing the content, but reorganizing the content, which is generally what refactoring is about. A system engineering context, which may contain software by definition in cyber systems. Some of those interfaces include physical flows, and the control of the system impacts those flows. So typically in systems I work with, there is some transfer of power or conversion of power. And therefore, there's some attributes that need to be physically managed, whether it be mechanical vibration, rigidity, shaft motion, electrical power, thermal. There's lots of things that need resolving. And therefore, avoiding flawed solutions has clearly more importance in the physical systems than in software because of this investment in our future needs and meeting all those demands. So I rather tongue-in-cheek stuck a couple of diagrams about the way we see the world as system engineers. So I took the medical regime and said, well, okay, the medical regime recognizes here are a few, it's an incomplete set of systems that exist in a human body. It is by definition a complex system. There's a lot of interdependence between these systems to make a human being. So a system engineering viewpoint would be not just look at the subsystem, but look at their interaction, their dependence. Whereas if I take the same approach with an agile viewpoint on software engineering, I go, oh, well, this thing needs to move around, so I'll give it a pair of legs. Okay, I need something for the legs to operate from, we'll give it a torso. Oh, well, and a pair of arms because we need it to grasp and do things. Okay, the head, we need some sensors, sound, vision, the ability to make noises. So I sort of understand that approach, but imagine the refactoring that would require and the cost of completion if you approached building a human body in that manner. The other thing that I always take delight in is the Scrum process. So you may be aware that in Agile processes, you will have these idea of backlogs. You have two stage type backlogs. You have the product backlog, which is a prioritized list of all the things the customer wants. Then you have a sprint backlog, which is the things that you're going to address in this iteration that you're going to deal with. And every time you finish that iteration, you go back and pick your next bit off the list. So there's no relationship here between the structure and behavior of the system. It's just go and collect the bits off the list in the priorities that the customer's decreed largely. So I always think that's like going to somebody and saying, "I'd like a house, please. It rains a lot here, so I want a roof on top." And after we've got the roof and we're under shelter, then I like to discuss how many rooms, floors, etc., should be in the house. And then when you've done all that, we'll discuss how the people in the house expect to use the house. You go to a civil architect, he'd be horrified because he'd start with who's the house for and how's it going to be used. So after going through all that, I thought, well, okay, let's try and rewrite the Agile Manifesto. So in system engineering speak. So I've left the old words in just so you can see the changes. So I reimagined the first one, say, our highest priority is to satisfy the stakeholders through frequent periodic delivery of validated system specifications of stakeholder valued features. You'll see I've got rid of what I call the ambiguous words of early and continuous, and we've turned that into system speak. I've deleted welcome because I don't think anybody welcomes change, especially project managers, and certainly in big complex systems, allowing the customer to change at will is not something I'd welcome. So accommodating changing requirements, even late in development, enabling the customer to understand the impact alongside the competitive advantage. So you're giving him a steer now, the customer, the paymaster, not necessarily every stakeholder, but you're saying, if you want to change this, it has this impact, this cost, this delivery impact. Is this what you want to do? I'm willing to accept these change, but you've got to accept that actually that's the impact on the program or the product. Deliver validated system specifications frequently, to my mind, is a restatement of number one, but it was worthwhile just making sure that people understood that. Business people, developers must work together. I just strike the daily. I think it's inevitable that they must work together throughout the project. For me, making the projects work is about using competent people with well-defined processes. And some people would say sharp tools. I use the word capable tools. I often find that people are more motivated by being able to get on and do the job with the good tools if they've got the good processes. The most efficient, effective method of conveying information is no longer face-to-face conversations in my world. The model is the single point of truth for all information in the team. I think this is doubly so with systems engineering. There's a sort of unspoken expectation in Agile world that all the software engineers are equally capable, equally experienced, and they have a common lingua franca. Whereas in system engineering, I might be talking to a hydraulics engineer one day, an electrician the second day, a pneumatics engineer the third day, a software engineer the fourth day, an electronics engineer the fifth day. They do not need to hear each other's conversations. What they need to understand is the bits of the model of the system that are relevant to them. In other words, filtered. And that's exactly what most models do. They filter it down to the viewpoints that each of those stakeholders requires. So working software as a primary measure of progress, I don't have a problem with the validated system specs being the primary measure of progress. That seems a reasonable KPI, considering our outputs are system specs. Agile process, I'm just going to delete the sustainable development stuff because I think it's not really a principle at all. Continuous attention to technical excellence. Well, in my view, a model containing a well-founded system architecture enables the impact of change to be assessed. I also think it's easy to modify good architectures. It's actually difficult to modify poor architectures. Simplicity for me is the art of minimizing accidental complexity. Typically for me, there are two types of complexity that go into any system. There's the essential complexity of the system itself, and there's the accidental complexity that's invariably put in by the engineers because they knew how to do something really whizzy with that bit and they really wanted to try it. But not necessarily needed. The best architecture requirements designed emerge from self-organizing teams. I disagree with that, and I think there's plenty of evidence. We'll come to that again later on, so I'm just going to delete it. At regular intervals, we retune, we get feedback, and we understand what's going on. I think that's reasonable, but in my case, we don't adjust behavior. We just tools, process, and competence. In Agile, it's behavior because there are no written down processes, etc., and the competences all assumed to be the same. So, having reworded all of that, I'm not sure I would call it Agile anymore, because although it's in the same pattern, I don't think it really reflects what Agile was intending to do. So let's look at the good, the bad, and the ugly then. So the brilliant parts of Agile, the bits that it does really well, it spends a lot of its effort in all its documents focusing on the stakeholders, the customer in their words, but in my case, the stakeholder. It's about delivering stuff that the stakeholders want. I think sometimes as system engineers, we do lose some focus on. Test, something they do get right is the fact that they understand that every time you introduce a feature, you need to test that feature and retest not only that feature, but the existing features. This should be doubly so for us as system engineers, where we expect high levels of dependence. If you had completely independent stuff, then you might question why you need to go back and test old features, because by definition, they were independent. You haven't touched them. But for us, that should be the real mantra. A bit that many people don't know is that in Scrums, you don't allow change while developing that feature. Essentially, at the point that a Scrum is started, the feature set is locked. And if somebody comes along and desires a change or decides that something you've got in that Scrum set is not appropriate, you carry on and develop it anyway. And it's only at the end of that Scrum you actually stop. Now, that probably works if your Scrum duration is short enough not to really worry you about the wasted effort. But I still think it's a good idea that once you commit to doing something, that you don't change it partway through. Engineers are not really good with dealing with change in general. Time box developments. So always finish a development, always come up with something that's useful and deliverable. If you can achieve that, really good. Back in the 1980s, certainly we spent a lot of effort having special to test equipment to make sure that even though the whole system wasn't available, that the bit we had done was going to work with the bits that hadn't yet been made. So the interface specs were, and the interface control documents were king. Project priority. So it tracks customer valued features. Again, that's a bit of a restatement of the focus view of life. Project manager in Agile might be known as the product owner, is a proxy customer. And in the Agile world, he is on behalf of all stakeholders. Now, from a software perspective, that might be relatively easy. In a system perspective, that gets more difficult, especially if we have a large number of stakeholders from a large number of different domains. All validation mechanisms are co-designed with feature design. Yep, if you want to know that you can build things right, you got to know how to test them to make sure they're doing what you expect them to do, or what the customer expects them to do, even more importantly. So that's the brilliant parts. The good parts, refactoring for simplification, where simplification is my definition of simplification, i.e. removing accidental complexity, but not at the expense of removing the upfront design. Regular protest meetings, not the daily in the Agile world, but I still believe that managers' main task is to remove impediments from the engineers to allow them to get on and do the job that they're asked to do. High bandwidth team communication. Yes, I agree with this. I don't agree with the face-to-face, all in earshot of one another, all learning by the conversation that's going on. But for me, a model is a persistent single point of truth, or the single point of the information that you want to disperse. But the relevant viewpoints in domain-specific languages. So filter the view on that information so that the engineers in individual domains only get to see the information for which they need to understand. They don't have to worry about, does it all connect up? That's the system engineer's job. Remove waste. Again, Agile is good at that, but their view of what's necessary work, being largely product, is yeah, well, it's questionable, isn't it? How do you judge what's necessary? How do you judge what's waste? I live in projects that have lifetimes that possibly stretch from years to, and in some cases now I've got a customer where the project is going to be 100,000 years because it's nuclear waste disposal. So deciding what is waste, if you didn't document some of those things and it's got to survive maybe 1,000 generations, that could be quite tricky. The hyped parts of Agile. So there are bits in some of the extreme parts of Agile, such as 4eyes or pair programming. They have never worked. There's plenty of evidence that they have never worked. Review always works. Somebody looking over your shoulder or doubling up never has value. Open space working. Well, I would have thought our COVID slots would have taught us that this is outmoded. And maybe in the days where we had no collaborative capability, it was true, but I don't believe this is the case anymore. I don't actually believe it was the case in the originally. Self-organizing teams and collective ownership. So my primary evidence for this is that if you look at open source software development, and I'll contrast that with Agile. If you read Raymond's The Cathedral and the Bazaar, which is all about open source development and the organization of open source development, you will find not very many use Agile methods to construct their software, unless they happen to have all the characteristics we've just desired, which is this massively independent sets of features. And there aren't many bits of open source software that do that. Working at sustainable pace. I think this was a response to, what shall I say, overzealous project managers who wanted delivery starting at day one. I don't think it ever changes the wish for more content earlier. I think we need to make sure that we emphasize quality and delivery as much as cost. In the Agile world, you potentially get it when you get it rather than on a planned time. And their estimation techniques, which they call planning poker, is not really novel. It's a simplified wideband Delphi method that was, I think, recorded by Barabin, probably in the early 1990s. Certainly I've used back in that sort of era. So the bad and ugly parts. So the bits you really want to avoid for system engineering. The deprecation of upfront tasks. The idea that you can not do any planning, not make any architect decisions, not write any documents. The idea that you don't have to worry about the whole system boundary. You only have to look at independent user stories one at a time because you will assume they're all independent. No consideration of alternative solutions. The first solution you think of is the right solution. And if it's not, you'll always refactor it. Well, clearly that's not going to work in system engineering. And the lack of focus on risk and cost. I have to remind myself constantly that most of what we do in system engineering is about mitigating risk and cost. It's about technical debt reduction, basically. So the Agile economics are about short-term savings, not long-term costs. In fact, if you were to look at Agile developments, they are often closely followed by what is classically called DevOps, which is where the software continues to be maintained by another team once it's actually deployed. Most of the systems I work with, the customer really wants to have a working solution, and he wants a maintenance schedule, which is about maintaining the system, not about making it work. The embedded customer, okay, that sort of doesn't really work, does it? So what's a customer? Which of my many stakeholders in my system is my customer? Are we talking just about the paymaster? And if it's not, in the embedded customer, do I have a representation in my team for every stakeholder, whether that be human or machine? And imagine the capability I expect from these stakeholders to be true representatives of their needs. Probably people who are not going to want to sit around in my system engineering team for a long time. Test-driven development. Personally, I think this is an aberration. I have two teenage sons who've recently been learning to drive or have learned to drive. And my view of test-driven development is it's like a driving test. You learn to pass the test. You don't learn to drive. Test-driven development has that same sort of feel to it. You're learning to pass the test, not necessarily making sure it works as it should. And the last bit of the bit that I find ugly, feature-based development with assumed independence. That assumption, I think, makes a mockery of most system engineering. If I went into a customer and said, okay, well, I'll deal with this stakeholder today, and we'll assume that it has no impact on anything else. When I start to look at the use cases across different stakeholders, it'd be very clear to me that actually they're not independent. It's all heavily dependent on the relevant domain knowledge and engineers. In software, maybe it's reasonable to accept that all engineers have the same capability, experience, knowledge level. With system engineers, that's rarely the case. And how would we develop system engineers? It's really quite difficult. It'll be done when it's done is probably culturally and contractually quite challenging, and failing to recognize the cost of providing test facilities for incomplete systems is really not a nice thing. But again, in the virtual world, your test facilities are there as part of your integrated development environment, so they don't cost anything. In fact, most of them come for free. The cost refactoring. So we ignored the cost commitment to domain specialist engineering. We assumed there's no significant investment. It's not just the cost of design work, but revalidation of those compromised elements. If I'm in a high integrity system, validating the final solution when there are no more changes to come can be just as costly as all of the aggregate costs of validating the individual pieces along the way. If I want to do that on a regular basis and invalidate what I've already proven, that could be quite significant. The other bit that's really quite tricky is rubbing Agile and its processes up against any form of standards. Why is that important? Well, again, if I want to develop system engineers, I really want them to understand the processes and tasks that they need to go through, the level of evidence that they need to generate, the appropriate synthesis and analysis that they need to do to ensure that their design thinking, etc., is appropriate. And if you haven't got a process, how do you assess whether the process is capable or even predictable? So, tail end, last couple of slides. So where Agile is more usefully applicable for SE, there are tasks within our traditional system engineering that are absolutely perfect for Agile processes. So the non-physical systems, obviously, so the business systems, the virtual systems, tasks with rapid independent iteration, prototyping, requirements solicitation, definition of user interfaces and user experiences with the customer, anywhere where incremental approaches might be reasonably applicable. Yeah, all of those things that have the little commitment to future investment, they also have high bandwidth communication with the individual stakeholders. So they're exactly where Agile is useful. And they're always in our system engineering at some part. But where Agile fails, recognizing SE is about cost and risk reduction and optimization. So refactoring, ignoring complexity, subsystem dependencies, it really doesn't understand the differentiation between engineering costs, operational costs, disposal costs. It only deals with generation of a product. It has no standards compliance, and it has these egregious, flawed arguments when comparing with the waterfall B lifecycle to give it its anecdotal claims that Agile is brilliant and all other processes are useless, when in fact their benchmark is not even the reality. So Agile may be tarnished as a brand for application to physical SE, but I still don't think that should stop us from using it where it's really useful, having first made sure we got rid of the future cost and risk. So that, I'm afraid, is my take on Agile SE. I am willing to take questions.
Yes, let's give Stuart a hand. All 26 of us who are on the webinar today, which is actually pretty good. for one of these. So you've done quite well, Stuart. I think you brought a lot of people in. But well done. Any questions? Oh, there must be somebody has something out there.
People with no variation in the mileage compared with my experience. No, that I find astounding.
Okay, who's had bad experiences with Agile? Who's had bad experiences with more traditional approaches? Anybody want to comment? No?
I would say people just digesting what they just heard and applying into their projects, so to see what can be improved.
I think for me,
go ahead.
Sorry, no, yeah. If the takeaway really is those two keys, if you apply those two key tests and say, are the use cases independent? And is the cost of refactoring this expensive or cheap? Those are the two key tests that you apply to whatever element of system engineering. And we break our system engineering up into lots of different parts and tasks. You should apply those two key tests to them. If you pass those two key tests, Agile has some real benefits. If you fail on either of those two key tests, steer well clear.
Good. Good, Mitt. It's kind of a go, no go check. Very
Absolutely.
good. Yeah. Has anybody out there been told they must do Agile and that it's required? Anybody in that situation or have a story about that?
Sort of. I can just relay more of a, I guess, a testimonial that I have heard on some projects where the Agile approach is considered modern and the traditional approach, as was just mentioned, is considered outmoded or outdated. And, they use that to sort of throw out the baby with the bathwater, I guess. Yeah. So I just, I've been on large projects where the supplier has said, yeah, we're doing Agile, so we're not going to worry about, we don't have a lot of time to worry about requirements. It's literally that Dilbert cartoon.
And I think there's an element of subterfuge, shall I say. People will claim Agile when what they've got is no process definition or chaos, and they can't be bothered to think about how they should plan their project.
Yeah, and another buzzword or buzz phrase sort of along those lines is fail fast or fail faster.
Yeah.
Which just lights my hair on fire, but I won't start there.
Yeah.
Was Agile invented by a contractor?
No.
Sort of feels like it, doesn't it?
It was a group of
We're just
Americans.
going to get on with it. Don't worry about it.
Yeah. No, it was a group of Americans.
See?
It was a group of Americans, and quite honestly, if you go back to the era in which they lived, there was an element of project managers beating software teams to death, and I think a lot of this was a backlash to that sort of horizon. But if you actually look at the genesis of Agile, it's not a singular proposition. It had a whole gang of people with a whole load of ideas who came together and they cherry-picked the bits that they thought were the most reasonable and came to a compromise solution, which they then formed under the Agile Manifesto.
Okay, Wendy, I see you have your hand up. Would you like to ask a question?
Yeah, really interesting presentation, Stuart. Thank you. A few years back, I was in a situation where the project managers were suddenly told to do Agile project management, as part of almost like a company requirement. So I guess these were people who'd been doing traditional project management for years, and then they were suddenly thrown into this Agile project management environment. And some of the projects where the project manager adapted really well to the Agile environment, projects went really well. But there were a few who sort of didn't really adapt very well to it, and that made the overall project a bit more difficult, I think, to progress in terms of progression. The other comment I'd add would, from these experiences, were: are you doing a project under the Agile methodology, or are you developing an Agile system?
Yes. And,
So
and they need to be able to
is it your
define that, don't
project
they?
that's Agile, or is it your system that's
Absolutely.
Agile?
Absolutely.
So that's my takeaway from it previously.
I saw a recent series of videos, I think came from the UK naval background, about how they're going to have these modular systems, and they'll have a what shall I say, a water-based carrier that you plonk down a load of cubes on it, and you rearrange these cubes to generate different facilities. It all sounds whizzy and wonderful, and the videos are first-rate sort of productions. But of course, they're incredibly flawed when you consider the power, thermal, etc. requirements that they're going to set on it. It's just not viable. So, you know, the system engineering approach is about system thinking, isn't it? It's about encompassing the whole and about understanding how that's going to play out. And I think that's the bit that, for me, that's really missing in the Agile world.
Hey, Stuart, we have Christopher Bosch. Would you like to ask a question?
Yeah, very interesting presentation, Stuart. I was just wondering whether the Agile approach could be used at the very start of a project where, you know, it's an entirely new thing. You've no real idea what the requirements are. You've no idea of what you can possibly build. And so you have this rapid process where you don't take anything very far, but it helps to put a boundary around what people want and what's possible. And then you step into the SE side of things after that.
Yeah, and I think for me, that's exactly where I would expect it to be used. You know, the conceptualization stage, where largely what you're doing is describing what the system must do and how it interfaces to the individual stakeholders. You're not really investing very much, because you're not saying what the solutions are going to be, how you're going to partition the system, what technologies are going to deploy. So all the expensive investment stuff isn't being done yet. But what you are doing is having a really high quality validating set of conversations with the customer. So why would you not do that in an Agile manner? Yeah.
But anyway, look, fantastic presentation. Thank you.
Thank you.
Okay. Anybody else? We have, it's ready on the half hour. Okay. Well, there is a YouTube link for all these videos, which Stuart will be posted as soon as it's ready, which I think takes a few weeks. Hokey, is that correct?
Okay.
No, it'll take a few hours.
Few hours, okay. Oh, well.
Few weeks.
Even better.
Well, look at waterfall here, you know, but
We're in the IT world.
Yeah. Well, if you, Richard, and all others, if you scroll up from the chat, then you can just simply subscribe to our INCOSE TWG YouTube channel, and when you subscribe and turn the notifications on, then when we post the webinar recording, then you will get a notification immediately.
Okay, and for those who saw the flyer, the link to the YouTube is on there, so you can easily get to it. And welcome. And anybody who wants to fill out the survey, please give me your email address. I've already captured quite a few in the chat, so thank you very much. And let's give Stuart another round of applause. And thank you again, Stuart. It was much appreciated. And quality speakers, that's what it's all about, huh?
Thank you.
Thank you. Okay, well.